Consumer product design has been undergoing a surge, with products getting smaller while their requirements grow. If we look at projectors, we've seen them move from standard definition to high definition, and now even 4K. We've seen the integration of Bluetooth, Wi-Fi, and various other connections. In conjunction with this, the desire to miniaturize these products continues to grow. Because of this, internal components face new challenges. Today we're going to look at a conceptual design for an internal bracket that stabilizes the lens in a new portable projector. A typical scenario for a bracket like this is a 3-point bending test to evaluate its feasibility and usage. We're going to attempt to solve this problem using the nonlinear solver available in SOLIDWORKS Simulation Premium. Let's take a look at some of the steps required to set up and run this problem. The first thing we're going to do is define our material properties. In this case, it's safe to assume that the supports are relatively stiff alloy steel and that the bracket itself is made from an acrylic material. We'll use a tangent modulus to define how the material behaves after yield. Now we'll define our boundary conditions and contacts. This problem has contact between the bottom fixtures and the bracket, and the top fixture will need to be displaced 20 millimeters downward while maintaining contact with the bracket. The bottom fixtures themselves have their outer faces restrained to prevent motion. We'll specify our mesh settings and use a draft quality mesh to increase the speed of the solver and also increase the likelihood of convergence. There are many solver settings we can adjust to help with convergence, but let's just focus on the number of steps to ensure we have intermediate results as the bracket itself deforms. After 20 minutes, we're able to get a result. We can see the deflection of the bracket, the stresses induced, and where we might need to modify our design for strength. But 20 minutes? For a model like this seems a little long. And if we'd like to investigate a bunch of different design alternatives or multiple load cases, that could mean hours and hours of solve time. SOLIDWORKS Simulation is a powerful and intuitive tool, and for most situations it will provide an adequate solution. But at this point, we may need to explore alternatives to solve this problem faster. Stay tuned for the next video, which will highlight how we can leverage the power of the 3D Experience platform and the industry-renowned Abacus solver to solve this problem.